Hello, in this video we're going to see relationship between sets. Let's say we have S is a set of all people. So all people are here, set S. And let's say we have M is a set of all males, humans, male. And we have a C is a set of computer science students. So they could be some computer science students that are male. So that's an intersection between the two sets. And this is S is all human. So M and C are both subset of S. So S is a bigger set and both M and C are subset because all elements of M and C are also element of S. So the male and computer science student, both of them are human. M is not a subset of C. However, since they are elements of M that are not in C, especially all male who are not studying computer science, this is all male who are not studying computer science, okay? For sets S and M is a subset of S, if and only if every element of M is also element of S. So this is how we write it symbolically. M, a subset, is almost like less than or equal, because M is a subset of S. All human, this is male. This is if and only if. For anything, if it is X, for all X, if X is a male, then X is human, or if X belongs to M, then X belongs to S. If M is subset of S, and M is different than S, then there is at least one element in S that is not element of M. Then M is, we call it proper subset of S. And symbolically, we write it M belong to S. This is almost like saying M less than, strictly less than S, instead of less than or equal to S. Cardinality of a finite set is simply the number of elements within the set. So the cardinality of S in the set, like what we talked about earlier, is the number of all humans, for example. How many we have all humans. By above definition of subset, it is clear that M, this number of male, right, must have a fewer members of S, which yield to the following symbolic representation. It's almost like if you say this M is a subset, proper subset of S, right? Which means this applies that M is less than S. Cardinality of M is less than cardinality of S. Let's see this example. A is X, where X is natural number and X greater than or equal to 5. That will give us the set 5, 6, 7, 8, 9, and so on. B, 10, 12, 16, 20. And C is X such that there exists Y and Y is natural number and X are 2Y. That means 2 whatever natural number N. That means 2 times 0 and 2 times 1, 2 times 2, which is 0, 2, 4, 6, 8, 10, and so on. So the best way to work on this is maybe, so let's see, is B a subset of C? Is B belonging to C? Well, B is all even, and this is our even number, so I would say yes. So, or true. Statement is true. So I would say that B is a subset of C. No. Is A a subset of C? Is A a subset of C? I would say no, because this have some odd numbers, and C don't have any odd number. So we say it's false. Now, is 11, 12, 13 subset of A? So A is 5, 6, 7, and so on, and eventually we'll have 11, 12, 13, 14, and so on. So indeed 11, 12, 13 is subset of A. Now this is a set. Once you have this curly bracket, and if you have set, you cannot use element of. We must use a subset, not this symbol. So this is false. But I will jump to the one next to it here. Is a set that has only one element, 12, a subset of B? Yes, indeed it is. B, 12 is a subset of B. So I would say true. I will also say that 12 is element of B. this is true. 12 is element. 12 an element. You put this symbol, it looks like E. So I'll continue here. X such that X is a natural number and it's less than 20. That means this can be 0, 1, 2 all the way to 19. So, and indeed B is 10, 12 is 0, 1, 2 all the way to 19, a subset of 10, 12, 16. No, it is not, and that's what we have, and this, therefore this is going to be true. Is a set with an empty set a subset of B? No, an empty set is a subset of any set, any set, especially like B. Yes, this is true, but this not, because I have a set within a set. How about this one? B is proper subset of A, which means all elements of B in A. You look at it, all elements of B are in A, and therefore it is proper subset. True. Is the number 26 an element of C? So 26 is even and C has all the even numbers, so it's true. The number 26 is an element of the set C. How about 11, 12, 13? Is this a subset of C? Remember, C has all even. I have 11 and 13, so I would say no, false, because 11 and 13 are not an element of C. Now, is 5 a subset? So 5 is element, not a subset. So right here I would say false, because this is element, cannot go with the set. This goes only with sets. So this is false. If I want it to be true, I have to say 5, the set with an element 5 is a subset of A. Is an empty set element? You see, I said empty set, and here is element. So this is a set and this goes with element. So right here is false. And again, if I had it this way, like this, that will be correct. If it was a subset, that will be correct. Okay, let's see this example. Given the description of a set A as a 2, 4, 8. That's all what they gave us, 2, 4, 8. Do you think 16 belongs to A? So, yeah, it could be, but not all the time. It depends what A is. All what's given is 2, 4, 8. So A can be X such that X is 2 to the power of N for N positive integer. So it will be, if I want to continue, so it looks like this. 2 to the power of 1, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, and 2 to the power of 5 is 32, and so on. So right here at this example, 32, or at this example, 16 is an element of A. But if the set A can be maybe the description of the following, where X equal 2 plus N times N minus 1 for N positive integer. So if N is 1, so I get 1 minus 1, 0, so I get 2. And if N is equal to 2, so 2 minus 1 is 2 times 2. So 2 minus 1 is 1 times 2 is 2. 2 plus 2 is 4. And if N is 3, 3 minus 1 is 2. 2 times 3 is 6. 6 plus 2 is 8. Sounds good now. So this is the same as where we started with 2, 4, 8. It does give us 2, 4, 8. But what's the next term? When N is 4, 4 minus 1 is 3. 3 times 4 is 12, and 12 plus 2 is 16, and 12 plus 2 is 14, not 16. Now if N is 5, you get 5 minus 1, that will give me 4. 4 times 5 is 20, and 20 plus 2 is 22. So in this case I keep going, but 16 is not an element of A. So based on this description, this description is not enough to know exactly what the set is about. So therefore, writing your set as follow, descriptive, is more appropriate than saying ... because sometimes we don't know what does it mean exactly. 2, 4, 8, what kind of set is that? So to answer the question, do you think 16 belongs to A? It depends on the description of the set, as we see in these two examples. Let's see this. We have A 2, 5, 7 and B 1, 2, 4, 7, 8, C is 7 and 8. Which of the following statements are true? So again, is 5 a subset? 5 is an element, not a subset. So right here I would say A is false, since 5 is an element of A, but not a subset of A. For question B, C is a subset of B. Well, C has 7 and 8 and B has 7 and 8, and that is true. How about C? An empty set, element of A, again I would say false, because this is a subset of A but not an element, meaning I need to use this as a symbol but not this symbol E, element of. D, 7 is element of B, yes. E, the set 2, 5 is a subset of A, yes. And again, an empty set is a subset of C, yes, because empty set is subset of every set. Now let's talk about set of a set. So from every set, many subsets can be generated. A set whose elements are all such subset is called the power set for a set S, and we write it like P of S. So for the set S that has 1, 2, 3, so the power set, either it's like what can be in this bag that has 1, 2, 3. It could be empty, it could have only 1, 2, 3, or 1, 2, 1, 3, 2, 3, or 1, 2, 3. So these are all the power set of S. So for a set within an element, so here you have 3 elements, the power set has 2 to the power of n element, and here we have 2 to the power of 3. If you count all of this power set, all the subset of S, it's 2 to the power of 3. As you see, there are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So let's find what is the power set when you have only one element A. It's simple. So the power set of S, so it's like you have a bag, it has only one element A. But what else can you have? Either you can have an empty set or one element. Because you have one element, so as you see, the cardinality of the power of set S is 2 to the power of 1, which is 2. What can be said about A if the power set of A is an empty set, an X and Y and XY? What's A? Well, A must be X, Y. And because if I do the power set or all the subset or possible subset of A, I will get this empty set X, Y and XY.